Okay, on to number 2, or question B. This is the product of the two functions. That's what f at x times g at x means. So in this case, h at x will be the product of the two functions. So we already know that the domain and range of those two are all real numbers, but it doesn't always mean that that's the domain and range of the new one. Sometimes there's restrictions on the original, sometimes there's restrictions on the new one, and sometimes there's restrictions on both. So when you multiply this out, you'll get negative 2x squared, and you'll get negative 2x, sorry, not negative 2x, you'll get 14x minus 1x, which is positive 13x, and then positive 7. So this is a quadratic that opens downwards because the initial term is negative 2, initial term coefficient. So this graph will have a maximum value. So there will be a restriction on the range because this graph will go up to a maximum value. So y will have a maximum value. Now, you could use your graphing calculator here, to give you an idea of what this graph looks like. So I've got that equation in there. I think I went zoom 0 to get it. You can find the x-intercepts, but the x-intercepts you can get from the original factors. Like when we wrote 7 minus x and 2x plus 1, those are the original factors of that quadratic. If you make both of those equal 0, they will tell you that you'll have an x-intercept at positive 7 and an x-intercept at negative 0.5. Let each of those original linear factors equal 0, because that's how we find the x-intercepts. So they are at 4, 5, 6, 7, and negative 1/2. But what the graphing calculator can really be used for here is to find out where that maximum point is, where the vertex is. Second function trace, number 4 for maximum. Looks like I can set my left boundary somewhere around 2, my right boundary somewhere around 6, and then enter. Try that again. Second function trace, number 5. Whoops, try that again. Second function trace, number 4 for maximum. I'll put my left boundary at 0, my right boundary, let me try 8 this time, and then there we go. So the maximum is at 3.25 comma 20.125. 3.25 comma 20.125. And so we can kind of guesstimate where that will be. I mean, it's going to be way up here somewhere. It'll be much higher than that, really, but that's okay. You could also look at the equation and know that the y-intercept is plus 7 because that's our constant term. Our domain is all real numbers. If I use set notation for this one, I would say all values of x such that x is an element of real numbers. And our range, here we have a restriction. All values of y such that y is less than or equal to 20.125, and y is an element of reals. So that would be the proper set notation. Set notation, you have to use those squiggly brackets. And you also have to identify the number system. So if you choose this, it has to be correct and complete. If you choose that method to write domain and range. Question C, you're looking at the quotient of the two, G on top and F on the bottom. So g on top, that's 2x plus 1. F on the bottom is my 7 minus x. So this is a rational function, and rational functions often have vertical asymptotes. They come from the non-permissive value of the denominator. Sometimes there's also a point of discontinuity, but those occur, remember, when you have factors on top and bottom that cancel. If those factors contain a variable, that gives you the position of a point of discontinuity. That's not happening here. But we do have a denominator that has a variable. If you let 7 minus x equals 0, then you're going to get x equals 7. That's where our vertical asymptote will be, at x equals 7. And this also has a horizontal asymptote. Remember that when the degree of the top and bottom are the same, the horizontal asymptote can be found by dividing the coefficients of those highest power terms. The coefficient of the x on top is 2. On the bottom, it's negative 1. 2 divided by negative 1 is negative 2. That's where our horizontal asymptote will be. And if you're drawing a graph that has asymptotes, you need to show those asymptotes. That's part of the graph. So you need to show them. Right? And now we can sketch the graph to know which quadrant, the quadrants formed by the two asymptotes, to know which quadrants our graphs lie in. We can just choose some random values of x on either side of the vertical asymptote. So my vertical asymptote is at x equals 7. I can choose any number less than 7 to find out what y is, to see whether it's above the horizontal asymptote or below. So I could use a value of x equals 0, for example. If x equals 0, you're going to get 1 over 7, right? And that's a number greater than negative 2. Y equals negative 2, which is where our horizontal asymptote is. We also could find, well, in fact, that is the y-intercept when I let x equals 0. So that'll be just above the x-axis, approximately there. And this confirms that the one arm of the graph is in that top left-hand quadrant. Normally, the other arm is in the opposite quadrant, the one diagonally across from it, which would be the bottom right-hand. But we can confirm that by choosing a value of x now that's greater than 7, greater than where that vertical asymptote is. So maybe x equals 8. When x equals 8, you're going to get 17 over negative 1, which is negative 17. So that confirms that it's below here. And so there's a sketch of that graph. For our domain, I'm going to use set notation here. All values of x such that x cannot equal 7. Otherwise, all real numbers. The range, all values of y such that y cannot equal negative 2, because that is where our horizontal asymptote is. If you use interval notation here, you'd have to do 2 for each of the domain and range. For the domain, you'd say from negative infinity to positive 7 with a rounded bracket, and then from positive 7 to positive infinity with rounded brackets. You'd have to do 2 for each of the domain and the range. All right, the last one that we're asked to do for h is an embedded function where f is embedded into g. So wherever you see the variable in g, you replace it with f. So g has 2 times x, the variable, but that is replaced with f. And then the rest of g is a plus 1. Can't forget about that. So that'll be 14 minus 2x plus 1, or negative 2x plus 15. So again, that's a linear function. The y-intercept is 15, which we don't have room for, and a slope of negative 2. So probably what I would do here is I would just choose a couple values, random values of x, find out what y is, and that'll give me some points. So looking at the equation, negative 2x plus 15, if I let x equal positive 7, negative 2 times 7 is negative 14 plus 1, plus 15, excuse me, is 1. So the point 7, comma 1 will be on this graph. When x is 8, negative 2 times 8 is negative 16, plus 15 is negative 1. So the point 8, comma negative 1 is on this graph. Let's find one more. Let's let x equal 6. Negative 2 times 6 is negative 12, plus 15 would be positive 3. So there's 3 points that lie on this graph. And they all line up, so we can be confident that we've done things correctly. And remember, our lines always have arrows on the ends. And the original functions have no restrictions. Neither does h. It's a linear function, no restrictions. So our domain would be from negative infinity to positive infinity. Our range is also negative to positive infinity. Number 2 says SE, which means it's a standard of excellence question. There's always a certain percentage of questions that are standard of excellence. I think it's somewhere around 20%, but on the inside of the first booklet, it should say that, the breakdown of what percentage of the exam will have acceptable standard questions and what percentage have standard of excellence. So standard of excellence normally involve more than one outcome in the same question. What does it say? Is it there? Doesn't say what percent are standard of excellence? No? Didn't see it? Okay. I'll see if I can find that information out. So for number 2, you're given f, g, and h. Here you've got 3 functions, and you're embedding h, o, g at f. So you're going to do 2 embedded functions here. And you always start from the inside out. So our first step would be to embed f into g. And then we'll do h at that. So f into g. Wherever we have the variable in g, which is the x, we replace it with f. So instead of x squared, it'll be the root of x minus 1, all squared. But we can't forget about the rest of g, because g also has a plus 3 on it. And in this case, when you square a square root, they cancel. You'll get just x minus 1 plus 3, or h at x plus 2. So now, for h at x, we replace the variable, the x, with x plus 2. So our final answer will be 2 times x plus 2 minus 5. That's 2x plus 4 minus 5, or 2x minus 1. We are also asked to include restrictions on the domain. So the simplified expression is linear. There's no restrictions on x there. But we have to go back to the original equations. H at x is linear, no restrictions on x. G at x is quadratic, no restrictions on x. But f is a radical function. There are restrictions on x because you cannot take the root of a negative number. X minus 1 has to be greater than 0, or equal to, I should say. Because you can take the root of 0, just not a negative. So if you add the 1 to both sides, there's our restriction on the domain. X must be greater than or equal to 1. So it doesn't ask you to write the domain. It just says, what are the restrictions? And x greater than or equal to 1 is the restriction. All right, next one, you've got two graphs. You're asked to use the following to sketch the graph of h, which is f plus g. So you might remember that when we did these, it's the y values that are being added together. So it might be helpful to start with a form of table of values. So all of the points that are on both the graphs of f and g come from x values of 0, 1, 2, 3, and 4. All of the points, that are on the graphs of f and g come from those x values. So now let's write the y values of the two functions. What is the y value for f at x, for each of these x values? So this graph is at 0, 2, 1, 3, 2, 4, and then it's 3, 4, and 4, 4. Getting those right from the graph. The y values for g for each of these values of x, this graph goes through 0, 0, 1, 1, 2, 2, but then 3, 1, and 4, 0. Those are the y values on g. In this case, h is the sum of the two functions. So we would add the y values together. 2 plus 0, 3 plus 1, 4 plus 2, 4 plus 1, and 4 plus 0. These give us the points on h using those same values for x. We will go from 0, 2 to 1, 4. The next point is 2, 6. Then 3, 5. And finally 4, 4. So here's the graph of h. Right? Number 4. Using that function, what is the value of f at 4? So you're going to do it twice, working from the inside out. F at 4 by letting x equal 4 gives us 16 plus 4, or 20 over 2, which is 10. So that's the value of f at 4. That equals 10. So now we have to do f at 10, because there's also an f in front of the f at 4. So now we're going to let x equal 10 in the expression, which will give us 104 over 8, which is 13. So there's that one. Number 5, you're asked to sketch them and determine those characteristics. Domain, xy intercepts, equations of asymptotes. So the first one cannot be simplified. It can't factor the top. But we can factor the bottom, and why we would want to do that is because that tells us where our vertical asymptotes are. If you factor that, it'll be x plus 4, x minus 2, which means that you'll have non-permissive values of negative 4 and positive 2. So we will have vertical asymptotes at x equals 2 and negative 4. Those are the non-permissive values. So we can put those on in there. Positive 2 and negative 4. Whoops. There is also a horizontal asymptote here, and we saw that when the degree of the top is 1 less than the bottom, then the x-axis, y equals 0, is a horizontal asymptote. So we can make note of that as well. We can say our horizontal asymptote is at y equals 0. We can find our x and y intercepts if they exist. Our x-intercept is where y equals 0. And a rational function equals 0 when the top equals 0. That's where 3x equals 0, so x equals 0. So in this case here, that means it's the point 0, comma 0. The origin is both the x and y intercept. And this example shows that there are some graphs that will cross through the horizontal asymptote at one point and approach it somewhere else. That happens. And we can see that if we put this equation in our calculator. So if I go 3x divided by, and I'll have to use brackets to keep my denominator together, it's x squared plus 2x minus 8. I'll go zoom 6 to set my windows to their standard settings so you can see what the graph looks like. If we go trace, it also confirms that the point 0, comma 0 is a point on the graph. Because when x is 0, it does tell us that y does equal 0. Remember, if we are at an asymptote or a point of discontinuity, the y value would be blank. It wouldn't show us a number. So this also gives us an idea of what the graph looks like. So we don't have to use any kind of a table of values to know where the graph goes. You certainly could, if you wanted to draw a more accurate sketch. You want to grab, there's 8 packages over there, Chase, to grab. We're going through the Unit 4 package. Right, so there's our sketch. And we have listed everything that we were asked to. So looking at question B. This one can be simplified. The denominator factors to x plus 3, x minus 3. And then the x plus 3's would cancel. So the simplified expression would be 1 over x minus 3. And because the x plus 3's cancel, that means that we would have a point of discontinuity at x equals negative 3, because the factor of x plus 3 canceled. And to find out what the y value is, we'll let x equal negative 3 in the simplified expression. On the denominator, negative 3 take away 3 is negative 6. So the point of discontinuity is negative 1/6. Okay, and because x minus 3 is the denominator that we're left with, that means we'll have a vertical asymptote at x equals 3. The degree of the top is 1 less than the bottom, so the horizontal asymptote will be at the x-axis, which again is y equals 0. So I've got a point of discontinuity at the point -3, comma, -1, 6, so that's just below the x-axis. I have a horizontal asymptote on the x-axis, a vertical asymptote at x equals 3. This graph will have a y-intercept. Our y-intercept is where x equals 0. So if we take the simplified expression and we let x equals 0, that'll be 1 over -3, or -1/3. So that's just a little bit lower than the point of discontinuity. This also confirms that the one arm of the graph is in the lower left-hand quadrant. And if you put the equation in your calculator, you will see that the other arm is in the upper right-hand quadrant. So there's the graph. Now, we were also asked to state domain and range. Didn't do that for that first one, so I will go back and do that. But let's do this one first. Our domain would be all values of x such that x cannot equal, and there are two places that we need to look at. One being the vertical asymptote, x cannot equal 3, but the other being the point of discontinuity. That is a hole in the graph. So x cannot equal both positive and -3, but all other real numbers belong to the domain. Same thing for the range. Y cannot equal 0 from our horizontal asymptote and -1/6 from our point of discontinuity. When you draw the graphs, you have to clearly show your asymptotes. You also have to clearly show that point of discontinuity. Some of you lost a half a mark on the exam because you didn't show asymptotes or you didn't show the point of discontinuity for the graph on page 2. You need to show those. All right, let's go back and do the domain and range of the first one. All values of x such that x cannot equal, we just have our two asymptotes, -4 and +2. And in this case here, the range has only one restriction from the y-axis. Y cannot equal 0. There is no point of discontinuity here. All right, this next one, we learned that when the degree of top and bottom are the same, the horizontal asymptote can be found by just dividing the coefficients of the highest power terms, which in this case is 3 on top and 2 on the bottom. That's it. When the degree of the top is less than the bottom, like we've seen a couple of those today, the x-axis, the line y equals 0 is your horizontal asymptote. When the degrees are the same, like this one, you just divide the coefficients of those highest term powers, or highest power terms. And when the degree of the top is greater than the bottom, that's when we get a slant asymptote. And that's not part of the curriculum to know where that slant asymptote is. You don't have to know where it is, but you can use your graphing calculator to see what that graph looks like to help. Number 7, point of discontinuity. They occur again when a factor cancels. So in this case, we would have to factor the top. And because x minus 7 is the denominator and we're told there's a point of discontinuity, that tells us that one of the factors has to be x minus 7. So that'll cancel with the x minus 7 on the bottom. And that means that the other factor has to be 2x minus 1, because those last numbers have to multiply to get plus 7. And if you do the outer and inner products, you'll get negative 14x minus 1x gives you your minus 15x in the middle. So again, the x minus 7 cancels. And because of that, your point of discontinuity is at x equals 7. And to find out what y is, take the simplified expression, 2x minus 1, and let x equal 7. That'll give you 14 minus 1, or 13. So there's our point of discontinuity. Looking at this next one. That graph can be written in the form y equals ax over x squared plus bx plus c. So we want to determine the values of a, b, and c. Again, this is a standard of excellence question. So we'll start with those vertical asymptotes. They are at negative 4 and positive 5. That means that x plus 4 and x minus 5 have to be factors on the bottom. So that's where we'll start. Because negative 4 is a vertical asymptote, x plus 4 must be a factor, and positive 5 is a vertical asymptote, so x minus 5 has to be a factor. Now we are going to have to multiply those out because the denominator is in the form x squared plus bx plus c. But before we do that, let's determine what a is. You can see that the point 2 comma negative 1 is clearly indicated as a point on this graph. That point must satisfy the equation. When x is 2, y will equal negative 1. So this is how I'm going to be able to figure out what a is. I'm going to let x equal 2. So on the bottom, 2 plus 4 is 6. 2 minus 5 is negative 3. So that's going to give you negative 18 on the bottom. And when you multiply both sides by negative 18, you'll get positive 18 on the left equaling 2a on the right. Divide by 2 and a equals 9. So now we can write the final equation and state our values of a, b, and c. We figured out that a is 9. And on the bottom, when I multiply out those binomials, I'll have x squared minus x minus 20. And so your values of a, b, and c, a equals 9, b equals negative 1, and c equals negative 20. This would not be a numerical response question because there's no place to bubble in negative signs on the scan sheet for numerical response. If you get a negative answer for a numerical response question, your answer is wrong. The only way that would work here is if instead they said that it was x squared minus bx minus c. Then you could say that the value of b there is 1 and the value of c there is 20. Then you could have this as a numerical response question. But you'll never get an actual negative answer for any numerical response questions because there's no place to bubble in a negative sign. So looking at some permutations and combinations questions. How many arrangements of all the letters of the word reason are there if the arrangement must start with an S? So there are 6 letters there. but the first letter must start with an S. So there's only one way that can happen. And then you have 5 other letters to arrange. There's no repetition there, so it's just 1 times 5 factorial. 5 factorial is 120 times 1 is 120. If all of the letters in the word diploma are used, how many different arrangements are possible that begin and end with the I, O, or A? So the word diploma has 7 letters. So we can mark down 7 spots. There would be 3 choices for the first letter and then 2 choices for the last letter. There are 5 letters left. They're all different. So there'd be 5 factorial ways of arranging those. So basically it's 5 factorial times 3 times 2, or 5 factorial times 6, which is the same as 6 factorial. The answer is 720. Josh wants to rent a car. He has narrowed his choices to a sedan, a compact, or an economy. They come in red, black, or white, and there's 2 transmissions, standard or automatic. How many options does he have? This is just fundamental counting principle. 3 things he has to choose. The type of car, sedan, compact, or economy, so 3 choices for that. The color, also 3 choices, and the transmission, where there's only 2 choices. Fundamental counting principle. You could do this using combinations if you wanted. It would be 3C1 times 3C1 times 2C1. Order doesn't matter. That's why combinations would be used. 3C1 is 3 and 2C1 is 2, so you'll get the same answer. A volleyball team made up of 6 players stands in a line facing the camera for a picture. Joan and Emily must be together. How many arrangements are possible for the picture? So mark down our 6 spaces. If Joan and Emily must be together, remember that they count as one object to be arranged. Plus the remaining 4 athletes gives us 5 objects to arrange. They could be done in 5 factorial ways. But we also must multiply by 2 factorial, which are the ways that Joan and Emily can be arranged amongst themselves. Joan first, Emily second, or Emily first, Joan second. 2 factorial is 2. So that'll be 120 times 2, which is 240. Determine the number of different arrangements using all the letters of the word accesses. If, first, it begins with exactly 2 S's. So that means that the third letter cannot be an S. It has to begin with exactly 2, which again means the third cannot be an S. So if we write down our spaces first, we've got 1, 2, 3, 4, 8 spaces here. So we have to have an S and an S. Now the next letter cannot be an S. All right, there are 3 S's altogether. We've taken 2 of them already, so now we're down to 6 letters. But the next letter cannot be an S, so now we have 5 choices. So those first 2 things are S's. Basically, it's 1 times 1. And so now we've used 3 of the 8 letters. Now we have 5 left. And they could be arranged in 5 factorial ways. But there is repetition. Of the letters that are left, there are 2 C's and 2 E's. So we have to divide by 2 factorial and 2 factorial. Because of the letters left, there are 2 E's and 2 C's. So it's 5 times 5 factorial over 4, because 2 factorial is 2, 2 times 2 is 4. 5 times 5 factorial divided by 4. 150 is the answer. The second one, it must begin with at least 2 S's. So there are 2 scenarios here that we would look at. The first being begin with 2 S's or 3 S's. And remember, the word or means to add. We already have our answer if it begins with 2 S's, that's 150. Found that in part A. So for part B, if it begins with all 3 S's, that means you have 5 letters left, but again, there's repetition. You have 2 A's and 2 C's. So you have to divide by 2 factorial twice. So this will just be 5 factorial over 4, which is 30. So it's 150 plus 30. The answer is 180. More and more now, you're going to see questions on the diploma exam where you have to write something. You have to talk about something to do with the question. In this case, explain why the answers are different. And so there's a good chance that on the written response, there are 3 questions there. Each question has 2 parts. One part's worth 2, the other worth 3, and sometimes A is worth 2, B is worth 3, sometimes the other way around. So 3 written response questions worth a total of 15 marks. There's likely going to be a question, one of those parts where you have to write something, explain. Okay. So in this case here, explain why the 2 are different, and what makes them different is that in part A, the third letter cannot be an S. That's what's different. So again, there's a good chance that there'll be a question somewhere in the written response, one of the parts where you have to write. Yeah. Can't hear you. Yeah. Sorry? It is an S. The third letter is an S. So you're going to have 8 spaces. The first 3 spaces are going to be the 3 S's. You had 8 letters to begin with. The first 3 spaces must be S's. So now you have 5 letters left. 5 factorial. So now you're back up to part A. Right. 5 times 5 factorial. In part A? First one of what? I don't know what you're asking me. First one of what? You're talking about the 150 beginning with 2 S's? No, because we did that in part A. It must begin with exactly two S's. And what that word exactly means, it means that the third letter cannot be an S. There are two scenarios that we're looking at here. At least two S's means you can start with two or you can start with three. Are you okay with the answer we got for part A, beginning with exactly two S's? Okay, so the other option is beginning with all three S's. So if you mark down your 8 spaces, the first 3 spaces are all going to be filled with S's. It must begin with all 3 S's. So now you have only 5 spaces left. That's where the 5 factorial comes from. Yeah? Okay. Yes?
I think she was saying you could have just done for part B, instead of doing beginning, you could have just done 6 factorial divided by 2 factorial. Times 2 factorial, but it's not
So where are you getting the 6 factorial from?
because you just,
What does the 6 factorial represent?
it's the 6 letters that could be in space.
But the third space has to be an S. You can't change the third space. It has to be an S. This scenario is beginning with exactly 3 S's. So you don't have 6 choices for the third letter. You have only 1 choice for the third letter. What you're saying is if you go 6 factorial, then it's divided by what?
2 factorial. You could have just done 6 factorial divided by 4 for all of these, instead of doing beginning or end, because if you have the 6, then you're factoring the idea that it could begin with S or it could begin with S. And it still fits
The third letter?
the third space.
But it can't begin with any other letter. It has to begin with an S.
It's at least, so
At least means 2 or more.
yeah.
So we did the scenario.
2 spaces are an S.
Mhm.
That third one could be an S. So the 2 are off the limits, and then the 6 factorial is in that space, possibly being an S.
So then you're just doing it in one step instead of 2?
Yeah.
Yeah, I understand you're getting the same answer. I'm just not sure if that'll work every time like that. It might. I don't know. I'd have to think about that. But does anyone not understand the way I did it? Because it works. And it shows the different ways in which we're satisfying the conditions that are laid out. I'm not saying that doesn't work, because you get the right answer this time. I'm just not sure it will every time. I don't know. I'd have to think about it and look at some different scenarios and examples and work through them. So is that what you were saying, Julie, doing it once instead of 2 different ones? Is that what you were kind of saying? Yeah? Okay. It might work. I'm not sure. All right, looking at this next one. Car dealership. They want to line up 10 cars of the same model in the parking lot. There are 3 red, 2 blue, 5 green. So they are identical. Identical models. The only thing that's different about them are the colors. So the 3 red cars are all identical. The 2 blue cars are identical, etc. Okay. So we've got repetition here. Now, they want to line the cars up in a row facing forward, determine the number of possible car arrangements if the blue cars cannot be together. So when we did these in class, we looked at 2 different ways that this can be done. Okay? So you might remember this. The first way was taking the other 8 cars and putting spaces down for the other 8 cars. And then we use different spaces, and these different spaces represent positions where the blue cars could be placed. So there are 9 places that you could place the blue cars. Now you're only placing 2 of them, but you have 9 choices for that first blue car. Right? So that would be 9 places for the first blue car times 8 places for the second blue car. And now the blue cars are done. So you have 8 cars remaining, and they can be arranged in 8 factorial ways, but we have repetition here. There are 3 red cars that are identical, 2 blue cars that are identical, and 5 green cars that are identical. So this is one way to do this. So 9 times 8 is 72 times 8 factorial, and that's divided by, in brackets, 3 factorial is 6 times 2 factorial is 2 times 5 factorial, which we've already seen is 120. So 2016 is the answer. That's one way to do it. And then we looked at a different way to do questions like this. When items have to be separated, when they cannot be together. The other way we did it was by taking all possibilities minus the possibilities with the blue cars together. So this is another way that we did these. If things cannot be together, we saw that we could also get our answer by taking all possibilities and subtracting the possibilities with the blue cars together. So all possibilities is all cars 10 factorial, but again we have to divide by the repetition. Minus, okay, if the blue cars have to be together, that means they count as one object to be arranged. Plus the remaining 8 cars give us 9 objects to arrange. But we also have to multiply by 2 factorial, which is the way that the blue cars can be arranged amongst themselves. And I know there's repetition, but we take care of that on the bottom by, once again, dividing by 3 factorial, 2 factorial, and 5 factorial. So we can simplify that second expression a little bit. We can cancel the 2 factorials. That makes things a little easier. And so now I've got 10 factorial divided by, in brackets, again, it's 3 factorial, which is 6, times 2 factorial, which is 2, times 5 factorial, which is 120, minus, I'll use brackets here, 9 factorial divided by 6 times 120 again. Close the bracket on that, close the bracket on the expression. We get exactly the same answer. So both ways work. Thank you. Okay, both ways work. Number 15 comes from that information. 14 different types of fruit are available. How many different fruit salads could be made using exactly 5 types of fruit? So these 5 students had different answers. 2 of them are correct. Pardon? Oh, okay. 2 of them are correct, so which ones? Who thinks Kevin is correct? Why not?
You have 14 group, or you, like the fruit salad has 14 instead of the 5.
Why is Kevin not correct? Kevin says 14 factorial. What does that mean?
Like how many sort of different combinations of 14 there?
It means he's choosing all 14. That's right. So we're told he's only choosing 5. So I know what you're thinking, Sathuni. Kevin's a dumbass, right? I know that's what you were thinking. I know how your mind works. All right. Then Ron said 14 P5. Alicia, you're shaking your head. Do you think Ron's a dumbass too? Why? Why is Ron incorrect? That's choosing 5 from 14. But don't you butt me, young lady. Okay, but that means choosing different ones. What's wrong with that? What does P tell you? No, P tells you that order matters. Order doesn't matter here, right? It doesn't matter what order you choose the salad, the fruit salads, or the fruits, I should say, to make your salad. It doesn't matter what order. At the end, you still have the same 5 different fruits in your salad. Michelle said 14C9. Is that correct? Don't think so? Well, if we use the combination formula, 14C9 means 14 factorial over 9 factorial, 5 factorial. Right? Okay. What do you think the correct answer would be? 14C5, which is what this means. If you look on the formula sheet, you'll see that's one of the notations used for NCR. We never really did it, but it's on the formula sheet. So this means 14C5, which if we use the formula is 14 factorial over 5 factorial, 9 factorial. So 14C9 is the same as 14C5 because 9 plus 5 equals 14. 14C9, what it really means, it means from the fruit salads, you're not choosing 9 of them, which means you're choosing the other 5. That's what it really means. They're the same thing. Not choosing 9 of the fruits is the same as choosing the other 5. What's wrong with what Jackie said? They're backwards, right? Plus they're permutations, but n always has to be greater than or equal to r. You can't choose more items than you have to choose from. So 3 and 5 would be correct ones. And in this case, the way that's written, if you wrote 5 and 3, that's correct as well, right? This doesn't say respectively or to write them in a certain order. So there have been questions on diploma exams where numerical response and their computer is programmed to answer, in this case, 35 or 53, because the order you write the numbers doesn't matter. Number 16, at a meeting, every person shakes hands with every other person exactly once, and there are 36 handshakes in total. How many people were at the meeting? We've seen questions like this before. This is basically saying that NC2 equals 36. Order doesn't matter. 2 people have to come together to shake hands. That's where the 2 comes from. How many people are there? And I mean, we've seen that you can use guess and check to find out what n is, but if this was on a diploma exam, it would definitely say determine or algebraically determine. So you have to show your work of where n comes from. So using the NCR formula, we'll have that expression. I would expand the top n factorial to n bracket n minus 1 and stop at n minus 2 and put a factorial on the end because that's our denominator. And at the same time, I would multiply both sides by the 2 factorial or multiply both sides by 2. 36 times 2 is 72. Again, the n minus 2 factorials cancel. You'll have n squared minus n minus 72 equals 0 that you need to factor. N minus 9, n plus 8. So that'll leave us with positive 9 and negative 8. But n, the number of objects or number of people you're choosing from, cannot be negative, so only 9 works. And you can check that on the calculator. 9C2 should equal 36, and it does. Okay. How many different four-letter arrangements are possible using 2 letters from the word smile and 2 letters from the word frog? So this one has to be done in 2 steps. The first step is choosing the 2 letters from each of the words, and then you have to arrange them. Now, the order you choose the letters doesn't matter. So for our first step, we can use combinations. Then we will arrange them, and that's when we'll talk about the second step, which will be a permutation. But originally, we have to choose 2 letters from the word smile, so that will be 5C2, and times 2 letters from the word frog will be 4C2. So there's our first step. 5C2 which is 10 times 4C2 which is 6. So there are 60 ways to choose the letters. And then they're going to be arranged. So now those 4 letters will be arranged. So we'll multiply that by 4 factorial. So 10 times 6 is 60 times 4 factorial gives us 1440. Question? You're good, Alicia? Yeah? Okay. So you have to choose 2 letters from each word, and then you will arrange them. Number 18, find the value of A if that has 18 terms. So remember that we saw that the number of terms is always 1 more than n. So n is always less than, or 1 less than the number of terms. The number of terms is always 1 more than n, so n is always 1 less than the number of terms. If this has 18 terms, n has to equal 17. So the exponent has to equal 17. So 2a will equal 22, and a will equal 11. Student made the following statements regarding the expansion of a plus b to the 4th. So there are 5 statements there, and 3 of them are true. The first statement, the total number of terms is 5. That is true, right? The number of terms is always 1 more than n. Second statement says that the middle term is 6a squared b squared. So, to check that, I mean, you can expand the whole thing if you want. I don't think we have to do that though. But we can check that the coefficient is correct by using Pascal's triangle. Right, the value of n there is 4, so we're looking for the row that has 5 terms. Number of terms is always 1 more than n. The other thing you can look at is that the second term has to equal n, which is 4. So that middle coefficient is 6, so that part is correct. Also remember that the first term would be a to the 4th, then a cubed, then a squared. That's correct. The first term will be b to the 0, b to the 1, and b squared. That's correct as well. So the second statement is true. Statement 3 says the sum of the leading coefficients of all terms is 14. Well, if you add these, 6 and 4 is 10, 11, 15, 16. The sum is actually 16, not 14. For the term 4a cubed b to the m, m must be 1. Well, that needs to be true because remember that when you take each term, when you add the exponents together, they have to equal n. N is 4, so 3 plus 1 will give you the 4. So that is a true statement. Statement 5 can't be correct because only 3 of them are, but here's the reason why. This says the leading coefficient of the first term is 4c1. Well, the leading coefficient is 1. That is actually 4c0, not 4c1. 4c1 is 4. That's the second term, not the leading term. So those are the 3 that are correct. The term in the simplified form of the sixth term in that expansion. So remember that the value of k is always 1 less than the term number. T sub 6 equals T sub 5 plus 1. Remember the general term is T sub k plus 1. So k is 5. So that'll be 6c5 a to the 6 minus 5. Whoops, I'm sorry. It's 7. N is 7, not 6. Let me fix that. N is 7. So it'll be 7c5 a to the 7 minus 5, and then negative 2b to the power 5. 7c5 is 21. You'll have a squared, and negative 2b to the 5th will be negative 32b to the 5th. You're going to multiply 21 by negative 32 and get negative 672 a squared b to the 5th. So there's that term. Okay, I'm going to stop there for today. We'll finish this off on Monday. You can start working on some of those questions in the question booklet for Unit 4. The answers are all on the very back, so you can always check your answers as you're going through these. Okay?